This screencast is all about time planning. So if we go back to our project planning process, we look at first step, identify activities and determine a sequence. That is our process map. Then we're looking at prepare estimates of time and resource and then present the plan. Planning is an iterative process, so we might find that if we can't hit our deadlines, we have to go back and maybe look at redetermining the sequence. And that's kind of the fundamental part of what we're going to look at in this particular unit. Some of the problems with estimating are that estimating is a posh word for guess. Parkinson's law says that if it's going to go wrong, it will. And the other issue is this, what we call the student syndrome, is where no matter how much time you set aside for something, you always leave it till the last minute. There are a number of approaches to estimating. One is ballpark, what do we think? Another one's called as-but. So, you know, well, this task is like the one I did last week, but a little shorter or a little quicker. Or you could kind of say, well, actually, I can work out exactly how long that's going to take me. For example, if I'm writing a large document, I type at X number of words a minute. Therefore, if I'm writing a 5,000 word document, it's going to take me 7 hours. Yeah. So there are a number of different ways, and sometimes they're mixed up to get a good mixture. So this is the fundamentals of scheduling and planning. When can we start? Forward scheduling. Backward scheduling. How can we hit that finish point? What can we do at the same time? As I talked about before in the process map, what must happen before this? What we call those dependent activities. And then every activity, we've got some slack time in any kind of overall project. And this is where we start thinking about the critical path. The critical path is where there is no slack time. We'll start getting to something called network analysis. So this is where we use diagrams because it's much clearer. Gantt charts are great, but they're quite simplistic and they don't let you see the critical path. So that's one of the most important things as a project, is to identify the critical path. So the key terms are EST, LFT and duration. So we're going to kind of look at how we represent a network diagram. So think about here from a work-based structure point of view in the yellow little post-it notes. This is sort of getting up and getting going in the morning, get ready, get up, shower, get dressed. A process map looks like the one beneath. So we've got the processes written inside the boxes with arrows between them. When we go to a network diagram, we transpose that and we put the processes with the arrows. Okay, so and then we have what we call nodes, these circular nodes, where at the beginning and end of every process step. Okay, and we do that because we're interested in time as well as interested in the process step. So a network diagram consists of the building blocks of these, a process step with two nodes either side, and it has an activity label and it has a T underneath, which is the time of activity. And then within the node we start putting some additional information, which is we can put a label in there for sophisticated analysis. We put the earliest time that event can start here and the latest time it can start here. So a thing about Santa Claus as an example, we've got 4 process steps and the time here in weeks. If we then look at putting that together in a process map, we can see that we can't wrap the presents until we've ordered the paper, and we can't load up the sleigh until we've wrapped the presents, and we can't wrap the presents until we receive the letters of what people want. Okay, so we've created a simple network diagram. So we put the steps in for each time, in for each step, and then we go what we call a forward pass. Okay, so we put the earliest everything can start. So received letters can start straight away, 0. It takes 4 days to do that, therefore, was it weeks? I can't remember, 4 units at a time to do that. So we put a 4 there, we put a 3 there, which gives us 7, and then another 1 there gives us 8. But if we look here, we can see that we can start ordering the paper straight away. So that's a 0. We then work back and put the latest everything can start. So we start here, and well, that's the latest it can start at 1 day, 7 days, back. And you can see here we've got some slack, because although we can start this at 0, the latest we can start, because it takes a day, 4 minus 1 is 3. So there is some slack in this particular process step. So therefore the critical path is on underneath. Obviously that's a very simple example. Planning is great in theory, but there are some problems on those things. And if you want to look at in more depth and more sophisticated analysis, the theory of constraints, you can apply that to project management as well. And that's kind of complex, but if that's what floats your boat, it's worth having a look. So the best way we're going to do this, to learn about it, is to use Ken's process map and turn that into a network diagram.